Slant asymptotes, or oblique asymptotes, are going to occur in our rational functions when the polynomial in the numerator is exactly 1 degree higher than the polynomial in the denominator. In order to find these slant asymptotes, what we'll need to do is divide these polynomials. So let's take a look at example 1. We have the rational function x squared plus 2x minus 8 all over 2x plus 4. Just like we would do for anything, the first thing we should do is factor this. So in order to factor, the numerator is going to give us x, plus 4 and x minus 2. And in the denominator, we have a GCF of 2. That gives us x plus 2. Okay, so nothing is going to cancel out here. That means there are no holes, and that's perfectly fine. The next thing we want are our x-intercepts, and we do that by setting the numerator equal to 0. So x plus 4 equals 0, x minus 2 equals 0. So that's going to give us x-intercepts of negative 4 and positive 2. We can put those on our graph. Then to get our y-intercepts, we're going to plug in where x equals 0. We'll substitute that in. So it doesn't matter if you want to go to the original function or to the factored form. That's 0 squared plus 2 times 0 minus 8 over 2 times 0 plus 4. And all those 0 terms cancel out. That leaves us negative 8 over 4 or negative 2. All right. From there, we want to find our vertical asymptotes. In order to get our vertical asymptotes, we set the denominator equal to 0. I'm going to go back to the factored form just because one more step has been done for me. So I have 2 times x plus 2 equals 0, which really means x plus 2 equals 0, or negative 2. All right, so from here, what we're going to need to do is figure out our slant asymptote. We know we have a slant asymptote because our numerator has a degree of 2, and our denominator has a degree of 1, and 2 is exactly 1 more than 1. So what we'll have to do is some long division. We'll divide the numerator by the denominator. So as we divide here, we have, 2x. In order to turn that into x squared, we'll have to multiply by 1/2 x. When we multiply, that's going to give us x squared plus 2x. All right. Then we're going to subtract, and when we subtract, we change both signs. And that actually all cancels out to a 0x. And we'll bring down that minus 8, and there's nothing that we can do from here. 2x goes in 0 times. There's no point in multiplying everything by 0. So we are going to get that our slant asymptote is the equation y equals 1/2 x. All right, so let's go back and see what that looks like. Remember, this is the form y equals mx plus b, so my intercept is 0, but I have a slope of a rise of 1 and a run of 2. So we'll start at 0, go up 1 over 2, up 1 over 2, and we can go in the other direction. Let's see. Okay, so there is our slant asymptote. All right, finally, what we need to do is get a few more points to see what's going on here, and that's where our calculator is going to come in. So for our y equals, we have x squared plus 2x minus 8, and that's going to get divided by 2x plus 4. All right, we're going to go to the table. I just want to count by halves, so I'm going to start at 0. We'll count by 0.5, and let's see what our table looks like. Okay, so for, let's find that asymptote. There it is at negative 2. To the right of the asymptote at negative 1.5, we're at negative 8 3/4. So that's going to be down here somewhere. At negative 1, we're at negative 4.5. And we have probably enough points. Maybe let's just pick something a little bigger than 2. How about at 4, we're at 1 1/3. All right, so we can see pretty well that we're going to get a curve similar to this over here on the right side. Now let's see what happens on the left. So let's go up. Let's see, just after negative 2, we have negative 2.5 gives us 6 3/4. Okay, negative 3 gives us 2.5. We already have a value for negative 4. Let's see, negative 6, negative 2, and that's probably a good enough amount of points. If you want more, feel free to see the curve that's going on there. All right. So we have that slant asymptote and that vertical. It is not possible to have both horizontal and slant, but it is possible for us to see vertical with slant. Okay. Horizontal, remember, occurs when either the degrees are the same or the degree in the numerator is smaller, whereas slant occurs when the degree in the numerator is larger by 1. Okay, let's try one more. So again, for this equation, we are going to factor first. So up top, we have a GCF of x. So let's take that out. In the denominator, we have a GCF of negative 4. And then we can factor one more time. So we have x, that's going to give us x minus 4, x plus 2. And then we have a negative 4, and that's going to give us x plus 2, x minus 1. Here we are going to get a whole. We see that the x plus 2's are going to cancel out. Okay. So when that cancels, that's going to give me x times x minus 4 over negative 4 times x minus 1. All right, so what canceled is going to help us find our whole. Remember, our whole is just a point. The x value comes from setting what canceled equal to 0, so x is negative 2. And then we're going to plug that negative 2 into the factored form to find the y value. So that's negative 2 times negative 2 minus 4 over negative 4 times negative 2 minus 1. So that's going to give us, let's see, negative 2 times negative 6 up top is 12. And that's 12 also on the bottom. We're going to get 1 here. So we'll have a whole at negative 2, comma 1. Okay. We need our intercepts the same as usual. Set the numerator now of the factored form equal to 0. So x is 0 and x minus 4 is 0. Then we can plot those points. The y-intercept comes when we plug in 0 to the function. So that's 0 times 0 minus 4 over negative 4 times 0 minus 1. And we're going to get 0 over 4, or just 0, which should make sense since we already have a point at the origin. Our vertical asymptotes come from setting the denominator equal to 0. So we have negative 4 times x minus 1 equals 0, or just x minus 1 is 0, so we get 1. And then from there, we're going to need to get our slant. And we know we have a slant by looking at the degree. The degree in the numerator is 3. The degree in the denominator is 2. Let's divide. Numerator divided by denominator. So we'll say to ourselves, negative 4x squared times what is going to give us positive 1x to the third. So that's going to be a negative 1/4, because that'll cancel out to give us 1 times x. And let's multiply. So that'll give us x cubed. That will give us a positive x squared. And that'll give us a minus 2x. All right, we'll subtract. So that's going to give us, let's see, negative 3x squared minus 6x. There is nothing to bring down other than technically a plus 0, so we could if we want. What do we have to multiply it by? Well, we're going to have to multiply by positive 3 over 4. That way the 4 cancels, but the 3 stays behind, and I already have that x squared. So when I distribute that, that will give us negative 3x squared. That's going to give us a negative 3x, and that will give us a, let's see, 6, I believe. We'll subtract. The x squareds cancel. That gives us negative 3x minus 6 down here. That is our remainder, but what we're concerned about is up here. So that gives us y equals negative 1/4 x plus 3/4. All right, so that is the equation for our horizontal asymptote. Y is equal to 1/4 x, or sorry, negative 1/4 x plus 3/4. Okay. So from here, we're going to plot our point at 3/4, well, our imaginary point, and we're going to count down 1, right 4. So at 3/4, we'd be here. down 1, right 4, down 1, right 4, up 1, left 4, up 1, left 4. So we can start to see that slant. Last but not least, we're going to type this all in and see what we can do. We get x to the third power minus 2x squared minus 8x divided by negative 4x squared plus 8. And let's take a look at that table. All right, we will plot our points. So on the left, we have, let's see, some nicer ones. At negative 4, we get 1.6. Okay. At negative 5, we get 1 and almost just shy of 2. What's at negative 5? Okay. At negative, let's see, with our whole. At 0, we get 0. We knew that. At 0.5, we get negative almost 1. Okay, so we can see that curve kind of start to form down here. And then over on the other side, we have at 1.5, we have almost 2. At 2, we have 1. And at, let's scroll a little bit, 6, we have negative 0.6. Okay, so again, we can start to see that curve.